So, good afternoon and good morning, and welcome back to the Snowbird Academy for the last appointment of this week. Today we are start to focus to talk about the uh, logs completion in geothermal project, logs during the operational completion. We are talking about temperature and pressure logging. So temperature and pressure logging are very crucial in pre-phase of completion of wells. After shutting wells pressure surely reach an equilibrium with the pressure distribution in the geothermal reservoir. During this time, the pressure profile measured in the well types pivot are fixed point called pivot point. In the well as a single feed zone, the pivot point is located at depth of the feed zone, and so the depth of the pivot point is essentially weighted the average of the depth of the feed zone of the well and give soil information. So we have this graph that plot the pressure, the different free wells pressure. There is a pivot point of NIT, and that underlines that in this area the pivot point of temperature, depth and pressure is a stability, pressure and temperature around this depth. So is an example to how to use this data for establish the condition of geothermal wells, and also to planning the all phases of completion. So when we are talking about the temperature logs, the purpose is to identify the geothermal gradients, detect inflow outflow zone, locate steam, water and entity points, confirm well completion integrity. Typical tools in high temperature platinum RTD, thermal caps and fiber optic. We have also the other tools that are used in geothermal logging, like fiber optics and high temperature platinum RTD resistance temperature detector. The interpretation is not so easy because we need to match the data also with pressure data. Sharp temperature increase might indicate inflow zone. Anomalies of inversion in gradient suggest cross-flow fluid mix or lost zone used for productivity index and reservoir modeling. Pressure logging, so in this case we are to talk about the pressure logging, and pressure logging is to determine the static or dynamic condition of pressure, calculate also the reservoir transmissivity and capability of storage, model inflow performance and pressure downflow, locate fluid level and pressure boundaries, quartz pressure gauges, and also strains conditions. So the interpretation of stable gradients for pressure and temperature is essential for underlying the hydrostatic condition and the dynamic water flow condition and fluid type present on reservoir. Pressure drops or steps indicate the feed zone scaling or free flow restriction. There is also important parameters underlying studying the flow restriction on the decrease of permeability. They combine the pressure and temperature log in this way. Shallow gradient and surface heating, geothermal gradient increasing pressure, high flow zone, and near when we have, for example, a temperature between this range of value and in this range of depth. Generally we have very high temperature, so the temperature increase in this range to 0 to 3000 is really constant, and because we have when we have not consolidated rocks, we have this kind of pressure. We have a shallow gradient and surface easy detected surface heating. When we change, for example, in depth, we have this temperature and we have this kind of pressure, geothermal gradient increasing pressure. We have also this kind of high flow zone near boiling point, and we have a possible superheated steam when we have this depth. When depth is measured than 1,150 meters, and we have a temperature much more than this value, and the pressure is around this superior of 15 megapascal. So is a high steam reservoir pressure, and is very difficult to manage, to control. We have much more techniques to make the reservoir monitoring, and so is much important to understand the condition of pressure and make the follow techniques to monitoring that. Which would be the possible logging scenarios. In this case, we can have a static logging or shut-in. Static logging for the true geothermal gradient and the equilibrium analysis is the first that I show you. In this case, we make this kind of slog, static logging or shut-in, in the first phase. In the first phase, when we make the drilling exploration. And when we make drilling exploration, we are doing this kind of plotting to understanding the static condition, to understanding the matching point of true geothermal and the equilibrium analysis between liquid phase and gaseous phase, and the stability of reservoir in state, the pressure, temperature condition. So dynamic logging during flow, for example, for locating contributing zone, fluid mix and scaling zone. We have the dynamic logging during flow. For example, in this case, when we have a dynamic log, we have this kind of situation. We have simulation of flowing temperature, pressure, but also the spinner velocity. So we are just in the pre-phase of production, and so we generally use the dynamic logging in the testing phase of pre-production reservoir. We want to also to understand that this kind of log, especially temperature logs, are much more used also in oil and gas. Why we are using, for example, temperature logs in oil and gas, we open a parenthesis because to evaluate, for example, the hydrocarbon maturation, the maturity of hydrocarbons depend on the maximum temperature or that organic remains just in time. And we have been subject to as well as time pressure and fluid movement, and that's the correlation and overpressure zone. These other parameters that we are used to analyze in the oil and gas. But just stay on geothermal reservoir, and we are talking to the second method, all second logging scenarios that are dynamic logging, for locating a contributing zone, fluid mix and scaling zone, simulation of pressure and spinner velocity of inflow zone. There is a simulation of spinner velocity in inflow zone in internal geothermal reservoir. We have a velocity around 1.5 meters on second. So this simulation underlines that we have two productivity zones. First inflow zone is around 800 meters depth, and we have a range of a change of pressure in this value. So the productivity in steam productivity is around this value for meters cube hours. This is a value of productivity. And the second zone is much more depth, is the double depth of the first zone is around this value, and we have a similar index productivity of 4 years. So is a geological and hydrogeological complex situation that with the two trapped geothermal reservoir. In this example, finally we can so we have also the graph that we are plotting and make correlation between the pressure and temperature in depth that underline the geothermal scenario is too trapped in this way because we have an high temperature and increase of temperature, and this way is a very pressured steam reservoir in this case. The first scenario is to talking the time-lapse logging, and the time-lapse logging is also called the 4D logging types. In geothermal reservoir involves recording temperature, pressure, and velocity logs, also at different times. So is based in a logging in times. So it's based on differential equation, and is used to observe reservoir evolution during production, and is just so. When the first scenario is used in establish the equilibrium is in the phase of study. The second is in the pre-phase of production. The last scenario is the type of logging using in during production and reinjection and stimulation of reservoir. So we have a summary of interpretation in this case. Cooling and pressure increase is observed, flow velocity rise. We need, for example, a reinjection, partial reinjection of steam and waters. Trace detect with local cooling spike, and velocity increase in this case. So we are plotting this in this way. So we have the different time in depth, and we have also the change in velocity between the first time and second time, and also the tracer concentration at finally situation. Thanks for attention and coming in, and we are see you next week.